Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
In 1916, Albert Einstein established a theory of relativity, which predicted the existence of black holes. Still, at that time, the concept was purely theoretical until 50 years passed in finding evidence of its existence. While studying the constellation Cygnus, the scientific community noticed a strange blue star, emitting blue X-rays. It wasn't just a still object, but going into a giant, black oblivion. Upon further research, what was found was truly terrifying. The star was being sucked into the black thing they were orbiting, thus the name black hole. This black hole was named Cygnus X1, 14 times brighter than the Sun, located about 6,000 light-years away from Earth. Let's dive into the definition of black holes. In the vast expanses of our universe lies one of the most fascinating and mysterious celestial mysteries of our cosmos. A celestial region where the force of gravity is so strong not even light, the fastest known entity in our universe, can escape. We all know how gravity works. It is the force by which a planet draws objects towards its center. The force of gravity keeps all of the planets in orbit around the Sun. Here is where the fascinating concept of escape velocity comes in. Escape velocity can be defined as the speed needed for an object to escape the strong gravitational pull of a black hole. For example, the escape velocity for the Earth is 8 miles per second, which means that the Earth has to travel 8 miles in a single second to prevent getting sucked into a black hole. Let's take an example of the Sun, with an escape velocity of 400 miles per second. The difference in their escape velocity is because larger celestial bodies have much more gravitational pull, and an increase in the gravitational pull also increases its escape velocity. You can say that if we imagine more massive stars, their gravitational pull would be so larger that the escape velocity exceeds the speed of light, and you wouldn't be able to see them. Let's discuss what the black hole looks like. There is an event horizon surrounding the black hole. It defines the boundary between the external universe and the interior of the black hole. If you dare to go across the boundary, as in into the black hole, you cannot escape its strong gravitational pull even if you travel as fast as the speed of light. Good luck with that. Another description of the event horizon that has confused people throughout the history of black hole research was the fascinating idea that the event horizon, when viewed from the outside of the black hole, is a place where time stops, and this is the direct prediction of Einstein's theory of relativity. Now the question is, what lies at the center of a black hole? We might picture an infinitely dense point at the center of the universe where a massive star collapses. When something crosses the event horizon, it collapses into the black hole Singularity, an infinitely small, infinitely dense point, where space, time, and laws of physics no longer apply. This is where a great revolution in black hole research was born after it was explored by Stephen Hawking. In his research, he elaborated that the particles forming the event horizon glow, produce energy, and have a temperature, which was named Hawking radiation. In his research, he explained that if we zoom into the event horizon and picture glowing particles known as the entangled particles, and suppose that if one pair of these entangled particles is on the inside of the event horizon, and the other one on the outside, it might escape into the universe instead of merging back with its partner. Hence removing energy from the black hole and causing it to shrink, which means that one day, it will be completely gone. But what if we get sucked into a black hole? There are millions out there in space waiting, and even if one of them swallows up the Earth, things are really going to suck, like literally. Will life continue to exist if we end up in one? Let's consider light and temperature. With the black hole's gravity bending light around itself, we would experience a phenomenon known as gravitational lensing, resulting in a strange and distorted view of the universe. The world will plunge into a perpetual winter, making it impossible for most life forms to survive. Not only will it affect the Earth's gravitational forces, but the strong tidal forces could tear the Earth into shreds. This process is known as Saghettification, causing the Earth to compress until it becomes a thin stream of matter spiraling into the black hole. Even though it's thrilling to imagine such a catastrophic possibility, it is also comforting to know that our Earth is safe in the Sun's gravity. But the universe is full of mysteries waiting to be uncovered. Until then, keep exploring, keep wondering, and keep on learning, until we really get swallowed by one.
Hope you like this story and learned something valuable. Then like, share, subscribe, and press the bell icon so you can keep watching new episodes.